Hello everyone, hope you all are doing well. In this video, we'll discuss the second problem of Leetcode BiWeekly contest 87. It's a medium level problem. However, I would say it's an easy problem as compared to the first problem that we have just seen in the previous video. Not cumbersome to code. That's why. Let's look into the problem statement. So we are given a zero indexed array, a zero indexed integer array players, where the ith value represents the ability of the ith player, right? So, and also you are given a zero index integer array trainers, where trainers of j represents the training capacity of the jth trainer, right? So two arrays, players of I represent the ability of ith player, and jth value in the trainers represent the training capacity of the jth trainer, right? So now the ith player can match with the jth trainer if the player's ability is less than or equal to the trainer's training capacity, right? Additionally, the ith player can be matched with at most one trainer, and the gth trainer can be matched with at most one player, so it can be one-to-one matching only. Return the maximum number of matchings between players and trainers that satisfy these conditions. So these are some examples. Let me just pull into the code and jump into the explanation. Yeah, it's I would say relatively easy problem. So you are given two arrays. Let's suppose the players array is 4, 7 and 9. This is players, right? And you are given the second array, let's 8, 2, 5 and 8. I'm just using the example given in the problem only. This is trainers. So what we need to do, we need to match players with the trainers, right? And a player can be matched in a trainer only if the ability of the ith player is basically less than or equal to the training capacity of the jth player, or in short, if the value, if at a particular index the value in player is less than or equal to the value at a particular index in the trainers array, right? Simple. So given the problem, again it's a greedy it's a problem that can be solved using greedy approach. Now how we know that? We know that because it says it's a one-to-one mapping. And also just think like this, that a player, suppose this player, now this player can be matched with any trainer. This player can be matched with any trainer whose ability is greater than or equal to 4, right? So if I pick a number which is 4 or greater than 4, we are good to go. I can match this player, right? Now just think that if I sort this array, suppose after sorting this array becomes 4, 7, 9, and if I also sort this array, right, so it will become 2, 5, 8 and 8, right? So just think of this player can be matched with any trainer whose value is greater than or equal to 4. So obviously I would want it to be matched with the trainer having the minimum ability which is greater than or equal to this value, right? Why? Because for the other players who are on the right side of this player, obviously chances are that these players will have a higher value, right? And if we want to match these players, we need a trainer also with higher values. So this 4 can be matched with 8 as well, right? This 4 can be matched with 5 and this 4 can be matched with 8 as well. However, if I match this 4 with 5, then there is a possibility that I can match this 7 with 8, right? Suppose this 8 was not there, suppose. So our array would have been suppose 2, 5, 8. So if we match 4 with 8, then this 7 cannot be matched. So the number of matchings in that case would have been 1. However, if we match like this 4, 7, 9 and 2, 5, 8, if we match 4 with 5, so this 7 can also be matched with 8. So in that case our answer would have been 2. So that means we follow a greedy approach where we match a player with the minimum value in the trainers array whose value is greater than or equal to the current value. Simple, right? So what we do in this case, it's a greedy approach problem. You just sort both the arrays, right, and pick up each player one by one. Just pick up this player and just see what is the minimum value in the trainers array that you can assign it, right? So just pick up implementation based problem. Let's jump into the code. What I've done, I've sorted. I'll tell you this explanation while explaining the code itself. So just sort both the arrays on line number 3 and 4. Answer equals to 0, j equals to 0. Now j represents which trainer I am talking about, right? So on line number 9, I have started a loop for all the n players. So I represents the ith player, and on line number 8, j represents the jth trainer, right? Now what you do, you take a variable boolean matched equals to false. So this value represents that whether the ith player has matched or not, right? Now what you do, on line number 11, you say that while j is less than m, that means while we still have a trainer left. So we check if trainers of j is greater than or equal to players of I. That means can trainer j be matched with player I? If that is true, then increment your answer. Also increment the value of the trainer, because this trainer has been matched, so you need to move to the trainer after this. So j plus plus matched equals to true, and you just break the loop, right? However, if there is no match, if a statement on line number 12 fails, then you just keep on incrementing j, because you need to match the current player, because if current player cannot be matched, all the other players after this player will also be will not be matched, because this player has the minimum value. So if a value 5 cannot be matched, then obviously a value 10 will not be able to match, right? So that is why we do this. And yeah, finally we keep on running this nested loop, and sorry, and finally we return the answer, right? The overall time complexity for this one will be, for sorting you use n log n and m log n time, and this is basically a the nested loop that we are running is basically big O of n plus m, right? You are visiting every index only once, hence it is addition, big O of n plus m. Hence yeah, we are able to get the solution accepted. So yeah, hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries or you want to solve similar type of problems, do mention that into the comments. I'll try to mention, probably I'll try to add some more problem statements, similar problems in the comment section, so you guys can practice. Also, if you want to connect with me on LinkedIn, then that is mentioned in the comment section. You can connect with me on LinkedIn. Also, take care. See you in the next video. Bye bye.